Question 9. A coin is flipped once. Let x be the random variable representing the outcome of the flip, where x is equal to 1, that is the probability of success, and when x equals to 0, representing probability of failure. What is the probability of success? That's question 1. What is the mean and what is the variance, right? So now let's understand what type of distribution is this. First of all, a coin is flipped once. Let x be the random variable representing the outcome of the flip, where x is 1. Now, I already said that for Bernoulli's trials, or for Bernoulli's distribution, the experiment is only performed once. That's how you know it is Bernoulli's trial or Bernoulli's distribution. The experiment is only performed once, right? And it has only two outcomes, either success or failure. Either you are successful or you fail, right? The same thing it is for us as university students. When you write your exam, when they release your results, it's either you fail or you pass. There's no two ways about it. It's either you go to 200 level or you face 10K. That's how it is, right? So it's either there is a success or there is a failure. So now a coin is flipped once, right? Let x be the random variable representing the outcome of the flip. What is the probability of success? So this is 1 over 2 straight away. There's no need to solve anything because you have just two possible outcomes. Either you fail or you succeed. So the probability of success in flipping that coin is 1 over 2, right? Is 1 over 2. So that's the probability of success. So now we have to find the mean and the variance. So now to find the mean, let us draw our table very quickly. So let me change this back to black. Alright, so our table, so here we have x and here we have f of x, right? So now we have just two outcomes, which is the first one where x is 1 representing success and where x is 0 representing failure. So the probability of success is 1 over 2 and the probability of failure is also going to be 2. So now you are looking for the mean, which is the mathematical expectation, is going to be equal to x, which is 1 times the probability of that value of x, plus 0 times 1 over 2. So this is going to give us 1 over 2 plus 0. So the mean is also going to be 1 over 2. And this mean for Bernoulli's distribution is represented with p. So either it's represented with e of x or represented with p, right? So now we're going to find the variance. Now the variance, which is vx or var x, anyhow it is going to be equal to pq, right? Pq, where q is representing the probability of failure. So this is just going to be 1 over 2 times probability of failure is going to be 1 minus the probability of p. Basically, q is equals to 1 minus p. As this p is 1 over 2, so we are going to be having 1 over 2 times 1 minus 1 over 2, which is going to give us 1 over 2. So this is going to be 1 over 2 times 1 over 2, which is 1 over 4, or 0.25. Now, some questions, they might not put 0.25, they might put, so this 0.25 is also 25%. It's the same thing, because 25% is equal to 25 over 100, 0.25, right? So whichever one you see in the options, 1 over 4 or 0.25 or 25%, it is the same thing. Alright, so now question 10% of tools produced in a certain manufacturing company come out to be defective. Find the probability that in a sample of 10 tools chosen at random without replacement, right? Before we look at the questions, now let's find out what type of distribution is this, right? Because the key to solving any question, because I believe that once you know the formula, the rest is history. You know the formula, you know the type of distribution, just apply the formula, you get your answer, right? But the issue will come where you do not know what type of distribution it is. So now this question 10% of the tools produced in a certain manufacturing company come out to be defective. Find the probability that in a sample of 10 tools, meaning that if you are taking 10 tools, 10 different tools, right? So it means that the experiment is repeated. It is repeated. It's not just carried out once. It is repeated 10 times, right? So that's the first thing. Repeated 10 times. So the number of trials is 10. because it's carrying out a sample of 10 So it took the first one, the second one, the third one, the fourth one, right? It's just carrying the two. So there's a trial of 10, basically. So now the probability of defective tools in the question is 10%, right? Is 10%. So P is equal to 10%. And remember, I already told you that 10% is the same thing as 10 over 100, which is 0.1. Let's deal with 0.1. Let's deal with decimal numbers and not the percentages, right? So now we can find Q from this, because we know that Q is equal to 1 minus P, right? So when you see this question, you already know that this distribution is binomial distribution. Remember, when the trials is more than 1, it is binomial. When the trials is exactly 1 or is only 1, it is Bernoulli. That's the difference between the two of them, and that's how you can identify what type of distribution it is, right? So now we already identified that. So now let's just write out the different parameters we can get from the question. The number of trials is 10. The probability of defective is 10%, which is our P. Then our Q is going to be 1 minus P, which is 1 minus 0.1, and this is going to be 0.9, right? So now we've gotten all this. So now the question is asking us that we should find the probability that it will be that 2 will be defective, that exactly 2 will be defective. So the first one, the probability that x is equal to 2. Remember from Bernoulli, our formula, when our formula is equal to n combination x, p raised to power x times q raised to power n minus x. So this is the formula for binomial distribution. So very easy. Now we're looking for the probability that when x is 2. So wherever we see x, we put 2. And this is our n. We already know our n to be 10 here. So wherever we see n, we put 10. So let's go. So we have 10 combination 2 times our p, which is what? 0.1 raised to power 2 times our q, which is what? 0.9 raised to power 10 minus 2. Okay, so let me get my calculator now. So we have 10 combination 2, and that will give us 45. So here we have 45 times 0.1 square times 0.9 raised to power 8, because 10 minus 2 is 8, and that is going to give us 4.304672 times 10 raised to power minus 2, right? And then when we multiply this out, multiply times 45, we are going to be getting 0.1937. So this is the probability that exactly 2 will be defective, right? Remember this question. This is the question in our flyer, right? So now I believe everybody can solve this question. So if peradventure it is your first question in the examination, you'll be able to provide the answer to this question. So now let's go to the next one. What's the probability that at least 2 will be defective? At least 2, meaning that 2 can be defective, 3 can be defective, 4 can be, we're saying at least, which means pata 2 will be defective. That means 2 and above. So right, so our probability now, we're looking for the probability that x is greater than or equal to 2, right? And the probability that x is greater than or equal to 2 is equal to 1 minus the probability that x is less than. Let me explain. So now let's say we have a number line now, this line here, right? Let's say, let me put a point here. Let's say this point that is here is 2, 3, 5, 6, 7, 8, 9, 10. And this place is 1, and this is 0, right? Because we are putting 0 because there's a probability that none of them will be defective, right? That will be 0, and then we have 1. So now we are looking for, now in this number line, you know that the entire probability cannot be greater than 1. So everything here must be equal to 1, right? So that the probability of this place here plus the probability of this place here is 1. So the probability of anything happening here plus the probability of anything happening here must be equal to 1, right? So now if we're looking for the probability that x is greater than or equal to 2, probability that at least 2 will be defective, meaning that 2 or more can be defective. So the probability that anything here, this is probability that 2 or more defective. That's what we have in this side. This one plus the probability here must be equal to 1, right? So now if we're saying that 1 is equal to the probability that x is less than 2, which is 0 and 1, plus the probability that x is greater than or equal to 2. Here we're having or equal to because 2 is also part, right? So now if we make p the probability that x is greater than or equal to 2 subject of the relation, this one here will go to this side and become negative, which is why we have this. So let me go ahead and cancel this out so that we can continue. It's going to take a while. Alright, okay, we're almost done. So now that we have established that fact, let me just write this back. X is less than 2. Now that no, it's not as if we cannot do that. The probability that x equals to 3 plus the probability that x equals to 3 plus 4 plus, it's going to be too long. But if we use this one, we have just the probability that x is equal to 0, that none will be defective, or the probability that 1 will be defective. So very simple. So we have 1 minus the probability that x is equal to 0, using this we're still using this formula here, right? Where our n is still 10, don't forget. So we have 10 combination 0 times p, which is 0.1 raised to x, which is 0, times our q, which is 0.9 raised to power 10, because 10 minus 0 is 10, right? So now plus 10 combination 1, 0.1 raised to power 1 times 0.9 raised to power 9. So now we're going to be having 1 minus, where's my calculator? So 10 combination 0, Jerry, which is 1, times 0.1 raised to power 0, which is also 1, times 0.9 raised to power 10. So that's going to give us 0.35, so that is not too bulky. Then we have 10 combination 1, which is 10 times 0.1 times 0.9 raised to power of 9, and this gave us 0.39. So now this is going to be equal to, so I'm just going to do this with calculator because we don't have enough space. 1 minus 0.35 minus 0.39, and then we get 0.26. So this is the probability that at least 2 will be defective. So very, very simple stuff. You just need to understand where the question is coming from. So let me just recap what we did here. Probability that x is greater than or equal to 2, right? When x is greater than or equal to 2, you know that the total probability must be equal to 1, right? So the probability that x is greater than or equal to 2 is going to be equal to 1 minus the probability that x is less than 2. Right? This is why we're using x. We can just do this and say that the probability that x greater than or equal to 2 is equal to the probability that x is 2, or x is 3, or x is 4, or x is 5. But you can see that we're getting 3, 4, 5, 6, 7, 8, 9, 10. It is too long. If you want to be doing this one inside your exam, you will get your correct answer, yes. But what about your time? You're not going to be giving the whole day, right? So now, using this one, it is going to be faster. You will still get the same answer. You can check it out and let me know. You will still get the same answer, because when you now do x is less than 2, that means the other side of the number line, x is less than 2, you have just 1 there, just 2 values. But when you do 2, 3, 4, 5, 6, 7, you have 8 values, which is going to be very, very bulky. So you do this and you easily get your answer.